All right, ladies and gentlemen, we are going to look at today some angle relationships that exist in circles. A lot of this can be found on a formula sheet that you can find in Schoology. A lot of it. So I'm about to show you 5 different relationships that exist inside of circles, and 4 of them can be found on that formula sheet. For some reason, this one's not. So let's talk about these ideas. Some of this first situation is not on that formula sheet because I want you to think about this situation related to the subject we talked about. If the vertex is on the curve of the circle, we call that an inscribed angle. Well, whatever the measure of that angle is, the arc is going to be double the measure. The angle will be half of the arc that is inside of that angle. That's a relationship we talked about last time. It's called inscribed angles. All right. So here with this situation, here we have a chord and a tangent, a line that's only intersecting the circle at one point. I want you to treat this like it's an inscribed angle idea. The vertex, because realize this tangent and that chord actually create 2 different angles. We have one angle here, and then we have a second angle here. All right. From the past, we should say, oh, look, we have a linear pair. So this, we'll call this angle 1 and this angle 2. We know angle 1 plus angle 2's got to equal 180 degrees. That's a past idea. Should probably put the 2 in there. Angle 1 plus angle 2 equals 180 degrees. Well, that chord happens to also split the circle into 2 arcs. Here we have one arc we can call X, and the other arc we can call Y. Well, we know the circle, those arcs add up to 360 degrees, which would be the total circle. So the relationship is we've got angle 1 there, and we have the arc X, which is inside of it. Angle 1 will always equal half of the arc that is inside of it. Angle 2 is going to equal half of the arc that is inside of it. So it's kind of like this inscribed idea, but realize if the angles add up to 180 and the arcs add up to twice as much, then the arcs should be twice the value of the respective angles. And we're going to do several examples coming up, so try not to freak out too much if this is a little bit confusing as of right now. Here we have a problem where we have 2 intersecting chords. All right. If those chords intersected at the vertex, we'd have central angles. All right. And those central angles would equal their arcs. But we certainly cannot say, first off, we know that this angle 1 and this angle 2 are equal. Those are vertical angles. Angle 1 equals angle 2. Well, angle 1 does not equal this arc up here since the vertex is not at the center. Angle 2 does not equal this arc that it faces because the vertex is not at the center. But angle 1 and 2 will equal the average of those arcs. If I average those 2 arcs, which means add them up and divide by 2, then I can find angle 1 or angle 2. Again, this formula can be found in your formula sheet, which can be found in Schoology and under Unit 10. Now these 3, although they look different, here's 2 secants, here's a secant and a tangent, and here's 2 tangents, but realistically they're all the same relationship. Each time we have an angle, I'll call that angle 1. We have a small arc inside of that angle, and we have a bigger arc inside of that angle. Same thing here. If I call this angle 1, there is a small arc, and realize that small arc only goes from there to there. There's a big arc that goes from there to there. Same thing over here. The small arc was this amount. The large arc was that amount. Same thing here. Angle 1, and we have a small arc and a big arc. Each situation looks a little bit different, but the relationship is the same. We can find the measure of angle 1 by taking the big arc minus the small one and dividing by 2. These are the basic formulas we need to be ready to apply for angle relationships. Again, don't forget about our inscribed angles and our central angles. Whatever the measure of this central angle is, if it's y degrees, the arc will be y degrees. Those have got to be the same. An inscribed angle is going to be half. So let's look at some quick examples to see how we could be asked to apply this. Here's the first example taken straight off of your test. So if the measure of angle ABC is 110 degrees, I didn't put any variables here, but I'd want you to know that we can pretty much find everything. Because remember, we have a linear pair here. If that's 110, the rest of 180 degrees would be 70 degrees over here. I can actually find the measure of the two arcs. This arc here, which is inside of the 110 degree angle, has got to be twice the value. I could subtract from 360 to get the other arc, or just double 70. Either way, you're going to get 140 degrees for the other arc. Okay? Again, I'm treating each of these angles as if they were inscribed. You have an angle whose vertex is on the curve of the circle. The arc inside must be double the measure of the angle. The angle's got to be half of the arc. Okay? Next kind of problem, again, the second problem we went over, two intersecting chords. The angle that's facing those arcs, we can use the formula, which says that if we add the arcs, I can find y degrees by adding the two arcs and dividing by 2, which is finding the average. 100 plus 60 is 160. If I divide by 2, I get 80 degrees. So y here is 80 degrees. If I needed to find x, again, be careful. Look for those linear pairs. If y is 80 degrees, the linear pair has to be the rest of to make a total of 180. Again, you can pause, rewind, watch me do the problem again. If you have questions about anything, that's what we need to be bringing to our synchronous class. That's why we need to watch these videos before we actually get to class. It's kind of important. Next example. So this is our other situation where this bigger arc minus this one and divide by 2, and I get here, but we're missing this idea. I want to do 100 minus this arc and divide by 2, and that's going to get me x. I don't need another variable, so I need to track down this measurement. Well, this mark here stands for congruence. If that's 80 degrees, oh, I got another congruence. That means I got 80 degrees over here. That means I know the measure of almost all of the circle except for this piece I'm looking for. If I add those three numbers up, I get 260. And oops, I probably should have looked at this a little bit closer, because that says this is going to be 100 degrees. It's supposed to be smaller. All right, I made a mistake. Let's change this number. Oh, the fun of live mathematical errors. Now these add up to 280. All right. If I take that from 360, that means this other angle is 80 degrees. 120 minus 80 would be 40. And that means this angle over here, 40 divided by 2, is 20 degrees. Sorry about that error. Oops. But make sure we're just applying the formula that we saw a minute ago, which was right here. I have this situation. I should be applying this basic formula. Same situation. I want the same formula. The big arc minus the small one divided by 2 should get me x. I know the big arc is 200 degrees. How am I going to find the small arc? Well, I know the whole circle is 360, and I know that it's been broken into 2 pieces. If one of the pieces is 200, the other piece has to be 160 degrees so that I get a total of 360. Now I can just proceed with my math. 200 minus 160 is 40. 40 divided by 2 is 20. Remember, these formulas that I'm applying, all this stuff that we covered earlier, there's a formula sheet that has almost all of this. Be aware, on the formula sheet, it does not have this situation, nor does it have our 2 basic situations that we covered last class. So take a look at these examples. Please watch these videos before you come to class so that in class we can practice more ideas and have you apply and be aware of what we're taking a look at, because we only have about 45 minutes to work. Okay? Good luck. See you in class. Be safe.